Now we are going to see the construction of hyperbola. The eccentricity is 3 by 2. Focus distance is 50 mm. Now, just like the construction of ellipse, here also we are going to follow the same method, except that the vertex point has to be carefully marked. In the case of ellipse, it was 2 by 3. So from the focus we have to take minimum distance, and from the directrix it will be a larger distance. Whereas here, in the case of hyperbola, from the focus there will be a larger distance, and then from the directrix it is a minimum distance. Now let us see the directrix. We have drawn the directrix now, and then here we can draw the axis of the hyperbola. Here as usual we can mark 50 mm to locate the focus. This is focus. This dimension is 50 mm. Here it is just marked like this. It is 50 mm. Now here we have to divide this focus distance into 5 equal parts, because the eccentricity is given as 3 by 2. The sum is 5. In the case of ellipse, you have marked the vertex point here. There was a 2 times of the distance here and 3 times was here. Now we have to mark the vertex point here. That means here the 3 times of the distance from the focus and 2 times of the distance from the directrix. Now as usual, we can draw a vertical line through the vertex and then transfer this VF distance, just like the same similar principle of your ellipse method. Just transfer this distance now. You say this point is C and this point is E. Now we have to join this C and E and extend this. We can extend this. Here also, just like ellipse, we can draw any number of lines that need not be of equal distance. Now let us name this point as 1 and 1 dash, 2, 2 dash, 3, 3 dash, 4, 4 dash, 5 and 5 dash. Now, just like the same ellipse method, you can take the radius of 1 dash distance, and from F you can draw one arc on the line 1 dash on both the sides. Similarly, we can take 2 dash. From F we can draw 2 arcs. Similarly, from 3 dash, from F we can mark the points here. Similarly, 4 dash, from F we can mark here as well as here, and 5 dash you can mark from the radius and take the center as your F. Now I have to extend these lines to get the cutting points. Now the points on the hyperbola is just obtained like this. This point, this point and this point. We can join these points by a smooth curve. This will not coincide, just like ellipse, this will not coincide. We can take few points and then we can leave. That will be your hyperbola. Now the curve has to be joined smoothly. Now here also we can just join this curve. So this is going to be your hyperbola. For this also, drawing tangent normal will be the same method. If you consider this is the point P through which if you want to draw a tangent normal, now we can join this P and F by a straight line. For this line, I want to draw a 90-degree line from F. So the procedure is very simple. We can make the minute diopter parallel to this line, one limb parallel to this line, and then we can tighten this knob. Now this unit diopter is set to 90 degrees. The other limb is 90 degrees. So using this other limb coinciding with F, we can just draw one line which cuts your directrix at this point. We say your G. So G and P can just join and extend it. That is going to be your tangent. This is your tangent, and then for this, if you want to draw the normal, you make the minute diopter limb parallel to this tangent line and tighten this knob, then bring this other limb against your P and then draw a line which is your normal. This is the procedure of constructing your tangent as well as normal for this curve. Thank you very much.